All right, so thanks all of you for coming to see me do my little song and dance here. I'm assuming you're here not because you are needing more work. You're probably like me. What you don't need is one more damn thing on your list. So I work for a company called Nice and Contact. I'm an engineering manager there, and I run the build and deploy team. The acronym is BAD. Yes, I snuck that past the CTO. So when it's time to deploy the software, that's us. We are painstakingly, carefully, lovingly, and handcraftedly taking that out to production and gently setting it down, hoping it doesn't break anybody because people can literally die. So it's kind of serious business that way. But we have a lot of things to do with that. My motto that I've adopted is make the right way the easy way. The reason being this. How many times have you met a person who wants to make the hard way, or excuse me, who wants to make the wrong way hard for you? Do you like this person? Do you like them at all? No. No, this person, you probably have a dartboard with this person's picture on it. So let's talk about the problem. I'm the problem. No, not really. I'm trying to help. So pretend you're me for a moment. You're managing both the deployment of everything, and you're also, as it happens, managing the lab because they need someone who knows how to deploy a bunch of systems and can get it out there people can test on. So we've got a lab. The lab, by the way, is composed of a bunch of clusters. In Contact Stuff, which if you were to call and say, order a Snuggie, they're a reference customer, so I can tell you their name, you would be talking through In Contact software to an agent who's working at their house or in a call center you don't actually know. At any rate, each of these clusters holds thousands and thousands of calls that could be going through at a given time. In the lab, I've got, I don't even know, last count was like 70 clusters. It goes up and down a little bit over time as people abandon them and I reclaim them to make a little VM space. But here's the thing about a lab, and this is probably the same thing with your lab environment and your test environment. The purpose of a test environment is for developers to do this with. They broke it. It's broken. The cluster is broken. Staging is not responding. Who did it? They don't know. Now, in fairness, if you have a legacy app, do you 100% know what was wrong with it? I mean, the things are big. They're complicated. They were probably written by somebody who quit 10 years ago, but they're still making money. They may be still printing money, so you've got to get them right. So, you know, the developers fall back on my favorite email. This is a meme made in frustration, by the way, by one of my engineers in Bolivia of, oh, there's an environmental issue. Are you sure it's not a bug? No, it's definitely 100% environmental issue. It's not me. It's not me. Really, 500 error is not your code. Okay, so they send an email off to us and say it's an environmental issue. They're off the hook now because they sent an email. This is great. Everything is wonderful. Yeah, everything is not wonderful in my world. So I've got a very real problem here. I've got a lot of systems in kind of an unknown state, and I don't know what to do with them. Now, to compound things, let's talk for a minute about my team. So this is my team hanging a TV in the office because we wanted something that would actually show a dashboard, and the TV on the wall didn't work. Well, we didn't have a ladder. We did have motorized desks. The motorized desk can only hold one person. You can see where this is leading, right? You have two motorized desks with one person on each desk, and you need one person to go each desk. This is fairly typical of the kind of character of solution you have to come to in these scenarios. What's broken? Something, so we're going to cobble something together. The thing about it is this works, right? Cobbled together solution that's stupid, but it works. My team is a bunch of various people. This guy here is a keyboardist in bands you've heard of. He started in network. The guy on the other side was a software engineer. The guy up in the upper left is a QA engineer. The guy on the upper right was a ski bum. That's me, for years and years. The guy on the lower left is just, unfortunately, got stuck in the picture. Sucks for him. But we've got this big mix of people, and I'm spread across 3 continents. Now, that's actually a really good thing in my case, because if you have to deploy code in the middle of the night and you can't break anybody, it's really nice to have people in India who can deploy the code after their first cup of coffee, as opposed to having to stay up in the middle of the night when we all know we make really good decisions, right? So we're also, as you may have heard this term, you can feel free to steal this, we're the someone team. As in, well, when we deploy this code, someone needs to change the web config on all 75 web servers. I said no to that, by the way. So that's us. We also have this problem of these guys are worried. They hear ChefConf, they see ChefConf, and they think, I don't know how to do all of this automation stuff. My job is under threat. Keep in mind, these are people who know how the system works. They know where the bodies are buried. If you're going to get somebody to train to automate, it's them, right? OK, so here I am. I've got a group of people. I've got an unpredictable schedule. I've got an unpredictable number of machines which are doing unpredictable things. I need some way to get an actual objective measure of things. And at the same time, I need some way to welcome in team members who, most of them I had to train how to use Git, which, don't underestimate what a pain in the butt Git is. Some of you probably learned it recently. I can see grins. Yeah, Git. Git merge. No. Damn it. So I've got this interesting combination of people and of hard work. And you probably have something like this in your office. The thing is broken. We don't know why it's broken. And of course, the real tyranny of the whole situation is the sprint cutoff. Remember how I was getting all those texts? My watch is still buzzing. It's ridiculous. Because it's the end of the sprint, and the product manager is writing them, and their engineering manager is writing them, and everybody's like, why have you not delivered code? And they say, I don't know, it's Todd. I mean, it might be, but it's probably not. So who are you? At least who I'm talking to, and if it's not you, you could bail, I guess. But you are probably new at DevOps. You probably don't have a totally cool system, lots of Kubernetes, lots of neat automatic turn-ups, scale-up, scale-down type of stuff. You may be working on a little bit of a shoestring. You may have access to a lot of machines, but you don't necessarily have all the knowledge. You don't necessarily have the ability to expand those machines. So you're going to have to kind of cobble something together, make do with what you have, say 2 motorized desks type of scenario. Most of my guys have an ops-heavy background. I have a dev background, and I will say that that's very bad dev. I'm a rubbish programmer. Wait for it, you'll see that later. And you may be like me in that you come to these things and you see these slides of logos, just giant swarm of logos, and you're intimidated by it because you're like, what do those things do? I recognize 2 of them and I don't know how to use them, and I recognize 3 as being logos, and that's about it. Finally, if you're not very busy, get out. Nobody likes you. Okay, on which note, I'm here to get you past that intimidation and give you a model that I used for how to make something that is stupid but works, to give you an idea of how you could make something that is stupid but works, and welcome in your people into joining you in the, hey, it's stupid but it works and we're learning type of space. Okay, on which note, first I'm going to intimidate you with logos. So my problem of wanting to know what the different machines are doing is, do they have stuff installed? Is it running? Well, InSpec's perfect for that, right? So I've got InSpec. Okay, we'll put the code in GitHub because, I mean, where do you put code when you don't want to put code? Put it in GitHub. Okay, I know I got a lot of machines and I need to make a bunch of copies. We'll use Docker for that. Okay, cool. So far, so good. Everything is kind of by the numbers, right? This is the reference case for how you use the software. So we've got Docker. We're going to make Docker containers for it. We'll need something to marshal those Docker containers. If I got to chest 60 machines, I got to get a message to 60 Docker containers if I want to do it once. By the way, don't do this on a work laptop during a demo. The laptop will crash in front of the CEO. Oopsie. But so RabbitMQ, the lowest form of life of queuing systems, because it's super duper works. It's not fancy, but it will work every time. And it's real easy, and they have good, easy to read, small words. Tutorials online you can use. We'll build some stuff with Jenkins, and I'm a Python programmer, so I really want to use Python to talk to RabbitMQ, but I'm also really lazy. So Ruby comes free with every InSpec container. Breaking it down. That was the least intimidating logo intimidation slide ever, because I need at least 4 or 5 more. But InSpec's there to run test code. It has one job. Ruby's there to start InSpec in the dumbest way possible, which you'll see shortly, and talk to Rabbit. Job comes in, InSpec runs, message goes out from job, pick up next job. RabbitMQ just sits there running a totally bone stock RabbitMQ. Make sure you put a password on it or you will find things in it. He knows. Docker is there to run it all self-contained. So I run Rabbit in Docker because I can run it on my own machine. Not 60 containers, but 1 Rabbit container. I can also run it on a host that I happen to have in the lab, an old ESXi host that was cool about 5 years ago, but does the job. And I can also run my Jenkins instance on it, because while I'm developing Jenkins, it's nice not to get the nasty grams from the real Jenkins instance that the people who know more than me maintain. Finally, GitHub holds your test code, and you could replace GitHub with basically anything for your code. GitHub's just convenient because it has good tutorials, and it's kind of the easiest one to tackle. Okay? So, logo intimidation's back. Let's talk for a minute, though, about what we're doing here. We are making it so you can put some InSpec tests in GitHub, and they will run on a bunch of things. So for a developer who's just learning some new coding language, or is just learning Git and just learning how to code anything in Git, you want something simple. InSpec's friendly, right? I mean, InSpec is very inviting as languages go. So we'll have them write InSpec. We'll have them check it into Git, and we don't tell them any of this. This is a secret between us and anybody watching this recording. We're hiding all the mess of how it runs behind the scenes. So now my developers, to put it another way, they can check InSpec in, and it goes to Git, and it runs on Docker, and it runs little worker images, and we got 3 worker images, possibly more. It goes up, hits the queue, goes in. They use a, can I do a laser? I can't do a laser. They use a website. In this case, I'm using an internal intranet website, which I can't show you at all. They were very firm on that. To make calls to Rabbit, and stupidly takes back JUnit, because beautifully InSpec puts out JUnit, and you can get a JUnit library off of any language you care to use. So, or how about this? The giant block of sneakiness is here. Developers need to worry about checking in InSpec. End users, who so far is my people, some of the developers, the NOC, basically anyone who finds it at this point, gets kind of excited because they can actually run some tests. Do you have people at your office who are the only people who can run tests? Are they stressed? Are some of you them? So yeah, we hide it all behind the giant block of sneakiness. But then when they're ready, we can dial that back. We can say, look, do you want to learn a little Ruby? Do you want to learn about how Rabbit works? Maybe you see the Jenkins file. You guys, though, are here for a little of the crunch behind the scenes. So let's get into the crunch such as it is. Starting over here on the left, we write some InSpec tests. Lots of privacy screening going on there because your particular application will be different from mine, and mine tells you the names of machines I don't want to show you. The finest Docker file you will ever see. Incidentally, if you're making simple Docker files, you'll find they pretty much all look like this. Take my code, put it in the container, grab the appropriate container from Docker Hub, in this case, Chef InSpec. Thank you, Chef people, for making that for me so I can be lazy. And run my Ruby code, cleverly named test worker. That's it, that's what it does. Test worker is over here close to me. So there's 3 parts of this code. We're going to actually run InSpec. We're going to use the Ruby trick of backticks, which is insanely dangerous because it will run whatever you put in there. All the security people in the room are cringing and look at me like, what have you done? Because it's very easy to insert SQL runs or any kind of crazy stuff you want. For our purposes, since it's running inside one little container and the only thing it takes is one message from a Rabbit queue, if you actually bother to secure your Rabbit queue, you have at least some layer of security. You may want to be a little smarter than me on that. I have something in there that actually parses out what's the job it needs to run. If you're like me, you have web servers, API servers, SQL servers, 3 kinds of BI servers, TTS servers, ASR servers, media servers, and whatever that thing called INT is, and I can't remember what it does. There's a few around. You're going to need some logic that says, which do you do? I observe it. You could pass it the data. This is where you kind of have to figure out what your own system does. If you have nothing but web servers, I'm so jealous, and you run the web server. Finally, this is the actual talking to Rabbit code. It pulls from the queue. It says, go run InSpec, and then it pushes the result back onto the queue. Dumb as a stump, every time. Sorry, folks at Rabbit, whose code I stole from your tutorial and cut and pasted. But you can cut and paste this. Their tutorials are phenomenal. The Jenkins file then is basically just building my container. And in this case, I actually turn up the containers at the same time as I do it. Because I'm running in an InSpec container, you can do a trick in Jenkins where you use Docker to turn up an InSpec container and run InSpec check. It's not that I don't trust my engineers who are new at InSpec to write really good tests that are actual real InSpec tests. It's that I don't trust anyone. So we'll run a quick check to make sure that there's in fact tests that they checked in. We build a file. Again, you can find this in the basic Docker cookbook or basic Docker tutorials, and we actually start a worker. So here is a sweet video I have made of me doing it. I'm going to be using Portainer to show you what's going on the Docker system. By the way, if you're going to learn one thing deeply, learn Docker from this.
I see the Portainer logo in your...
Oh, yeah, you're right. I'm cheating. No Portainer logo. Should have done that for extra fun. So I'm going to use Docker Compose to fire up a test worker and the actual Rabbit queue. Blah, 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 builds it, does the thing. So we've got a test worker and we've got the actual queue. But one worker's lame, right? Because if we want to run InSpec serially on our machine, we could do that with a cut and with a replace. So we'll use Docker Compose to turn up 3 workers, not 60, as previously mentioned. Boom. My crummy work laptop is now a good testing machine. 3 workers and an actual rabbit queue that they're going to talk to. At this point now, I can't show you the internal website, so we're going to use some fine command line utilities. First things first, I'm going to have a Python utility that just looks at the output and tells you whether it passed or failed and totals those up. So this is watching the actual results queue on the one side. Rock and roll. Now we need to throw some servers at it. So I'm going to throw API and web servers at it because those are fast and I don't have to explain a lot what they are. We'll throw 10 of them at it right now. And we'll see what happens. Now you may have SQL servers, you may have other servers. If you make your logic inside sufficiently smart to know which profile to run, you could have a whole mess of profiles sitting in this worker. I recommend having every profile in every worker so it doesn't matter who picks it up. Oop, there's an API there fast. So everything's chewing away in those 3 workers. Obviously you could expand your workers if you have enough hard drive space and power to do it with. So we see an API works. Another API should be along shortly. That, hold the phone. The web servers are not looking super good right now. 45 fails, 45 fails. So when we see consistent failures like this, suddenly now you learn both about your servers and about your InSpec tests. That could be an InSpec test that's bogus, right? Because it's really consistent with 45, right? APIs seem okay. As it runs, we start to get more information about it. Oh, another 45 fails on the web server. And the punchline is this guy, 44 fails. Okay, now something is up. We just tested 10 machines in a matter of minutes. Assuming you can scale big enough, that also means you could do your 60 machines in a matter of minutes. Would anybody care to guess what was missing from those machines with the 44 fails? How about antivirus? Oops. But we found it. Good demo. Also a nasty gram from me later. Let's talk about what the effort to actually build something like this is, because there is effort, right? You see all these demos and they're like, look at me, I whoop, 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 whoop. I pushed a button and a website deployed. I'm just not impressed by websites deploying anymore, because don't just run websites. We have SQL servers, we have all a mess, right? Most of them, 3 tutorials a pop. Most of them have really good tutorials that are written. A couple that I got to call out specifically. Wes Higbee's Pluralsight on Docker for Windows is the bomb. If you want to get basic Docker and be able to use Docker as just kind of a day-to-day tool, which you should because it's awesome, this is the one to go to. It also means you don't have to be good at any of these things, which is particularly useful if you're me. Annie Hedgepath's blog also is a particularly great resource for InSpec. The InSpec docs and tutorials will give you the basics of how InSpec works. Annie's blog actually talks about, here's how you use it in like the world. Yeah, and GitHub, get someone to show you how to GitHub. Be ready to show someone else, by the way, how to use Git. Don't underestimate the intimidation of when Git comes back with a nonsensical error message to someone who has not used it before. That'll stymie you. Oh, and swearing at the computer helps. Always, always helps. If not that, you'll feel better. So you're thinking to yourself, okay, he made a thing, whoop-de-doo. How did it actually work out? Not bad so far. Could be better. That's the nature of something that's stupid but works, right? So success-wise, as I mentioned, Git is intimidating. And I have trained, I would say, about 12 people how to even connect to Git. Here's how you make an SSH key. Here's how you get into Git. And they've actually been really excited about that because nobody bothered to tell them. Everybody said, oh, well, you just use Git. It'll be fine. Use Git. The other thing is we're starting to ask the right questions now. Like, oh, thing failed because, computers fire. Well, why? I don't know. Do we have a test to see if it does that? Okay, now we're getting into the real questions. The actual repeatability, which is where the money comes from in this, right? Also, it's really coming around to a point where we're going to assume tests. So it's one thing to say, we need to make a test. It's another to say, why don't we have a test? This is a very different mindset that you're coming at it from. Well, why don't we have a test for that? Gosh, because no one wrote one. git clone, go write one. Don't worry about the mess. It's all hidden. It's all sneaky. All is not perfect, of course, as with such things go. You have to get a few successes with this stuff to be credible. You have to be ready to make it, and you have to be ready to get it wrong, and you have to be ready to have nobody believe you that this is going to be a good thing. Show up from ChefConf and be like, InSpec is great. I heard everything about InSpec. We all need to use InSpec, 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 InSpec. And everybody's going to be like, wow, they give you a lot of beers, huh? But on the other hand, you do something like say, yo, I was making my demo and it turns out antivirus isn't running on these. Could you, fix that? They're like, wow, okay, that's kind of real. All right. And then, next time you discover that, gosh, the patrol agent from BMC, which is monitoring software, is also not running on a bunch of things, but it's only running on the odd-numbered ones. That was a fun one. And you discover that, gosh, the reason it's not working is your code version on this machine and this machine is different from these machines here. Everybody's favorite web server problem, right? 2 bad web servers in a pool of 10. Yeah, you go mad fixing that one. But you know right away. And suddenly, now it's just a bug. And you know what to do with bugs. You go and you fix a bug. Or you blame it on the other team, as the case may be. Which brings up one problem here, the other team problem. There's going to be bits of this that you know and are good at. I'm decent at Docker, and I'm OK at programming, and I'm pretty good at thinking of tests. But at least I know who to call to get better tests. But I'm rubbish at websites. I'm super bad at websites. If you found some of the old ones I made, you would be terrified and run screaming from the room. But I know people. So I pull in another team that makes the internal website to make it. He comes back really fast with a website that'll run against a whole bunch of clusters and then goes to his new job. And there's no one to maintain the site. So give some thought to who you're bringing in to help you out around the corners of this. Because if we go way back, oh, it doesn't do fast clickies? Oh, whatever. If we go way back, and you remember the slide with the sneakiness, you have to have something that there's no nice way to say it, you have to have something that the normies can use to interact with your system. They don't want to command line, ever. They want to click on a thing and wait a minute and see a test. Now that may be Chef Automate, depending on how you want to tackle it. It could also very easily be your own website, which just calls Rabbit behind the scenes, which, by the way, there's a tutorial for on Rabbit's site in the language of your choice. But someone's got to build that. And if you're good at websites, good on you. The other thing is now suddenly your tests are a product. And this is this is the most stressful part of this. You've just written a test, and you've checked a test in. Guess what? The whole room is now going to use those tests. No pressure. They're just, basing their job and their work off of that. So you're cool. You don't have to stress out. Does your test work in all scenarios? Uh-oh. Let me just go and make perfection. No. Just be aware that it's a product, which means you can have bugs. Now your tests can have bugs. Your tests can have bugs in them that say, like, virus scan is not enabled. It turns out, incidentally, virus scan wasn't enabled in that case, but then we changed virus scans and all the tests went absolutely berserk. You're dying, you're unsafe. Because we didn't bother to change the test to put the new one in. So you've got a product, and you need to maintain the product. You need to make sure the product is good, and maybe, just maybe, talk to your customers a little about what they need in the product. So, the pep talk part of this. You can do this. No matter what your current skill level is, everything on there is stuff that you can go and read 3 tutorials for each thing roughly and manage something with. If you have already a step ahead in some things, good on you. You've made up some of your distance. But as you do this, you need to think about how you're doing it. Don't do this to say, nope, you're wrong, nope, you're wrong, nope, you're wrong. Your goal is to make tests that pass a lot, but find things when they're wrong. You don't want to be the Noposaurus Rex. Okay? We all know the Noposaurus Rex, and we do not love them. Don't be the nope. You want to say, well, I see what you're doing, and that's not quite the way to do it. Let me give you this way better thing, because people are lazy, and they will always take the easy route, that is the correct way to go. Your job is to make that easy for them by hiding a bunch of stuff. Also, just be bad at 5 things. You can be bad at stuff and admit you are bad at stuff. They will tell you, come and talk in front of a room full of people and tell them what a crap programmer you are. It's okay. Because now it's okay for everybody in the room and everyone you're talking to and everyone on your team to be not great at stuff and to learn together. That's an incredibly vulnerable, welcoming way to be. Finally, there are going to be setbacks. There's going to be a lot of setbacks. You're going to have some part, oh, don't be the Noposaurus. You're going to have some part which is custom made that doesn't fit between the radiator and the engine. Fucking bike. And so you're going to get your biggest wrench, and you're going to start wrenching on it as hard as you can, and maybe a beer to calm down a little bit, and then a drill! Because, you know, you're going to show that bike who's boss, right? Absolutely. And what is this even here for? Like, this doesn't fit. Nothing's going to fit. Nothing's going to go together. There's going to be a communication thing where the Docker container can't talk to the other Docker container. I feel safe saying that because that will always happen. And then your queue is losing things, and you're not subscribing to the right thing, but then there's going to be this weird moment where you're just in the thick of it, and all of a sudden, your Jenkins is going to go green. And be like, oh. Ooh, ooh, and you're going to run it again because you're not sure, right? Because that could be a fluke that it went green. You got to see it go green twice. And you realize that you've just made a thing, and it's not a normal thing, and it's not a thing that somebody else would design, but it's your thing, and it works. And you've got this wide open space in front of you now to play with it and start making improvements to it and get some value out of it. And then invite everybody else in to go for a ride with you because it's a sidecar ride. Also, maybe you should get back to the office. This was totally on a weekend, I swear. So thank you for coming in and listening to me. If there are questions, I would love to hear them.
How do you test your test?
I'm sorry?
How do you test your test?
Test the tests. Mostly what we'll do is we will have a reference. It's DO99. It's just a cluster designation we have that I keep everybody else out of. We make sure it's working, we make sure it's in the right spot, and we use that to kind of run the tests against. We also run InSpec check every time the tests build just to make sure that it's actually not a malformed thing. The test is definitely an ongoing battle because a bogus test that gives you flaky results is worse than no test at all, by far. So when I say test is a product, I mean like it's an important product. Great question. Yes?
How do you handle environmental specific tests?
How do you handle environmental specific tests? You know, it's funny you should say that because I was just at the chef booth asking them about that. Couple different ways. For the smaller profiles, you can use the inheritance model doing profiles. Like there's a bunch of inheritance stuff that's the same for everything. The virus scanner, you write that once and you pull it into all your other profiles. So they suggested doing a master profile with all the things and then you just inherit some of the things. You can also use attributes, I'm told, to do it. I don't know how yet. Still working on that. Every once in a while, one of the tests for something really expensive will fail on a dev cluster, and I have to remember to go and alter the profile. But it's a very real problem. If you don't have that perfect, it's the same everywhere, probably because it's really expensive. You have to compensate for that somehow. Others?
I have a quick question. So, sorry.
It's fine. You can.
When you talk about like writing the test in InSpec, what I gathered from yesterday's workshop is you can use the existing profiles like CIS and all that, and then you can also build your own profile. And I think that's what you're talking about.
Yep.
So, is there any examples where you can share with us as to how does building your own profile looks like and what kind of effort that is involved?
I don't have examples I can show because I don't have them in the slide deck. I'm happy to talk afterwards, though. If you want to, I can pop open the laptop and take a look. One of the pieces of advice I will give about writing profiles that we had to learn the hard way is pick an app at a time to write a profile for. We had some engineers, some operations folks, who popped in and said, all these ports need to be open. Port this, port this, port this, port this, port this, port this. It's a not terribly useful profile. On the other hand, a profile that says the virus checker needs to be running, it needs to have these files, file, 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 it needs to have this port, da, 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 da. That is one file, the virus checker .rb, whatever, is really the way to tackle it. I'd be happy to talk after and show you some of the kind of how we structure it. And you?
Yeah. Could you use the same worker to test in a kitchen environment?
I don't know enough about kitchen to answer that. So the question was, could we use this worker to test in a kitchen environment?
Yeah.
In the back says yes.
Yeah.
The guy who knows what he's talking about says yes, you totally could.
So you can specify a worker rather than having your integration tests built into your cookbook repo, which is probably the pattern most of us see, right? Is that our InSpec or smoke tests or integration tests are built into the cookbook, but in an ideal world, maybe you have those outside the context of the cookbook, and you can specify them in kitchen, but you can also specify them when the nodes are converged and live.
Yep. Yeah, so the notion of you have them in the cookbook and maybe inherited into the cookbook from the same repo, and then your workers run on the same test. Yeah, that's a really good idea. I'm stealing that. That's the real wonder of not knowing 100% what you're doing. If somebody comes up with a good idea and you're like, yes, now it's a thing. 100%. But yeah, the nice thing that I like about the worker notion is it's an external force checking. That's InSpec's really coolest thing about InSpec is you don't have to, if I say I have to install an agent on the machine, there's at least 2 engineers who will take me out back and kick me until I stop complaining about it, because we have too many agents on the machines already.
Can you get the results to automate?
From this, probably you'd have to have Automate watch the output stream somehow. I'm not sure. I'm not sure how the integration with Automate works. We don't have Automate. We have other things. Okay, so yeah, sounds like you could push the output from InSpec to Automate.
And vice versa, so you can have Automate reach out, do a scan, basically profile, and then it'll report it back to you as well. Yeah,
okay.
Good. It's just we have a weird network in Azure with like express routes. And that doesn't
Weird networks?
So that's why this design is awesome.
What must weird networks be like? No one here knows what a weird network looks like, right? Yeah, that's actually one of the advantages I like about the worker too, is the weird network problem. I can turn up a Docker host in my lab environment and go to town, and I can turn up a much better written and more secure one in production and go to town from within that context there. Other questions? All right. Thank you all for coming. If anybody wants to talk to me afterwards, I'm going to hang around. Thank you so much.